Good day, class! Today, we will tackle a car crash investigation. What you see in the screen is a Newton's cradle, which proves its law of inertia. The law of inertia states that it is a property of matter that causes it to resist any change in the state of motion. In this car, there is a passenger. The relationship of the passenger to the car is that the passenger travels at the same speed as the car and will remain at the same speed until acted upon by an outside force. Why are seatbelts important, if you ask? As we said earlier, the passenger is traveling at the same speed with the car, and when encountered with another force opposing the force of the car and the passenger, a collision would happen and will make the passenger experience an energy that is not experienced in a daily basis. So, why do seatbelts save lives? As we see on the screen, it says that seatbelts dramatically reduce the risk of death and injury. Why so? In a crash, the seatbelt slows the speed of the occupant so they impact safely in with the airbag. What is momentum? Momentum is equal to the mass of an object multiplied by its velocity and is equivalent to the force required to bring the object to a stop in a unit length of time. As we see here, if you have a lot of momentum when you kick the soccer ball, it will go faster. If you do not have enough momentum, the distance of the ball that it would go to is not that far, unlike when you have a lot of momentum. In this case, the player kick it with a lot of momentum, which causes the ball to go faster and farther. The formula of momentum. Like I said earlier, the formula for momentum is mass times velocity, which results in P equals m times v. What changes in momentum within collision? In a collision, momentum force acts upon the object for a given amount of time. The object's velocity is changed, and hence the object's momentum is changed. As we see here, we have two cars. It crashed! As we go back to Newton's third law, an object will remain in motion until acted upon by an external force. As these cars are traveling in the opposite direction at the same speed, both cars stopped in the middle as their speed and weight are the same, which insinuates that at the time of collision, their speed will be zero and their force will be the same. How Newton's third law applied to crashes. In crashes, Newton's third law is applied due to the fact that an object is moved by an outside force. Try to imagine a moving bus at a constant speed and it hit a car that is not moving. And once the bus hit the car, it moved together. That is where we encounter Newton's third law, which is inertia. Compact zones in a car. In new model cars, it has a crumple zone. The longer the crumple zone, the longer the time it would take to crash. That being said, the longer the time, the lesser the force, and vice versa. Wipe of 5 campaign. 8 Wipe of 5 campaigns has been released, emphasizing that even a small reduction in speed can make a difference between life and death. For example, a car traveling at the speed of 60 kilometers per hour would emit a force of 139,000 joules, while a car traveling at a speed of 55 kilometers per hour will be 116,739 joules. By converting the speed of the cars to meters per second, we would get 15.28 meters per second and 16.67 meters per second, which results in 55 kilometers per hour and 60 kilometers per hour respectively. By computing the kinetic energy it releases, we would get the amount of force it would give when in time of collision. The formula for kinetic energy is 1/2 multiplied by the mass and velocity squared. So let us put in our data to get the amount of energy the car has. Let us say that the cars are both 1000 kilograms, so that would mean 500 multiplied to the speed of both cars, one for 60 kilometers per hour and another one for 55 kilometers per hour. Once computed, we would get 139,000 joules for the 60 kilometers per hour car and 116,739 joules for the 55 kilometer per hour car, which is 16.01% lower than the 60 kilometer per hour car. As we see here, the Wipe of 5 campaign can really make a big difference with the force it releases and can actually increase the percentage of someone surviving a car crash. So for me, I am all in for this campaign.